Welcome to Brain Vision.
Hi there. So in this problem, we have a function g, and the variables there. G is a function of r and s. But we're also to think of this as a function named f, and its two variables are x, which depends on r and s, and y, which also does. So let's make a little tree diagram, just as in the book. So our function f depends on x and y, but each of x and y depend on r and s. That'll help us keep things straight. Okay, also relevant, we care about the point when r and s is 1, 2. And both questions have to do with finding partials of g when r and s are 1 and 2. Well, we're going to need to figure out what x and y are as well when r and s are 1 and 2. So let's write down what these functions of x and y actually are. So x, and now we can just copy right out of the book's definition. X in this case is 2r minus s, and y in this case is s squared minus 4r. Okay, and now the reason we want that, we'll use it later, but now we can figure out that when r and s are 1 and 2, we can figure out what x and y are. Just plug things in. So when r and s are 1 and 2, let's see, for x, we have 2 times 1 minus 2. So 2 minus 2 is 0. That means x is 0. And likewise for y, let's plug in 1 for r and 2 for s. 2 squared is 4 minus 4 times 1. 4 minus 4 is 0 as well. So now we know that at this point that we're dealing with, r and s are 1 and 2, but also x and y are both 0. So that will be useful. Okay. Let's get started. And if we need partials along the way, we can take them as we need them. So we are asked, first of all, to find g partial r at the point 1, 2. Okay. And now we can use our tree diagram. So we want to get down to the variable r. So we'll have to go down both branches. So starting on the left, that f to x means f partial x. And then the point we're taking this at, because f is a function of x and y, our inputs are 0, 0 there. And then we want x sub r, so x partial r. And now we're into r and s coordinates, because that's what x is given in, so we're in 1 and 2. All right, likewise, the other side of the tree diagram, f goes to y, so that means f partial y at the point 0, 0 times, and then y partial r at the point 1, 2. Okay, so let's see what we can do. F partial x at the point 0, 0, well, we can just take that off of the table. So if we look at the table they give us, that comes out to 4. And so this, just from the table, is the number 4. For this next part, x partial r, well, here is our definition of x. So x, the derivative, partial derivative with respect to r, we can see just at a glance it's just going to be 2. Right, independent of what r and s are. So in this case, it doesn't even matter that our point was 1, 2. All right. Plus, once again, let's use the table for f partial y at 0, 0. And the table says that is the number 8. And then finally, for y partial r, once again, we can use our definition over here of y, and we can see, again, at a glance, the derivative with respect to r is minus 4. Just another constant. Okay, so we have our first answer. 4 times 2 is 8. 8 times negative 4 is negative 32. So we should end up with minus 24 as our answer for that first one. Now to get g partial s, we do the exact same thing. So this should feel very familiar. We go down the tree again. So the only difference this time is we want to end at the variables s. So we'll go down these green branches so that we end at s. So we get f partial x at 0, 0 times x partial s at 1, 2 plus f partial y at 0, 0 times y partial s at 1, 2. Okay, we can use table of values here. And in fact, these first ones, these red ones, they won't change. We took those from the table before. So those are still the same as they were. This was 4 and this was 8. The only thing that'll change will be the partials of x and y with respect to s now instead of r. So over here on the left, we're going to want, here, let's just keep track of those here, also in blue. So as x partial s, if we look at this, well, the derivative of 2r minus s with respect to s is just minus 1. It's a constant. And the derivative of, let's see, partial derivative of y with respect to s, well, y is s squared minus 4r, so we get 2s. And again, we're doing this at the point 1, 2. So let's see, negative 4 plus 8 times 2. What is our s value? Well, at this point, it's 2, right? At the point 1, 2, our s variable is right there. So 2 times 2. So negative 4 plus, let's see, 8 times 4 is 32, which will give us 28. Hopefully that helped.